So because right here we're multiplying and dividing rationals, and you remember that the word rational means fraction. So it tells you exactly what you're supposed to do to multiply fractions. You multiply numerator times numerator and denominator times denominator, and then you reduce by canceling. Now, that says for monomials. What does monomial mean? This is an example of a monomial. This has one term. This has one term. This has one term. This has one term. We've done this before. This is going to be like x to the third power and 26xy multiplied by what are we going to multiply by? 14, 1, 2, 3, 4, 12x squared. Now, when you multiply these together, you multiply numerator times numerator and denominator times denominator, so this line can go all the way across. All of this stuff on top is multiplied together. All of this stuff on the bottom is multiplied together, but in order to make it easier, we're going to cancel as much as we can. So, this x cancels this x. These two x's cancel those x's. This y cancels that y. We have as many x's and y's canceled out as we possibly can. Now let's work on the numbers. 8 and 26 are both even numbers, so both of those will divide by 2. 8 divided by 2 is 4, and 26 divided by 2 is 13. 14 and 12 are both even numbers. 14 divided by 2 is 7. 12 divided by 2 is 6. Now, there's one more canceling I can make. Look at the numbers. Any numbers reduce some more? 2 goes into what? 2 goes into 4, and 2 goes into 6. And so 2 goes into that 3 times, 2 goes into that 2 times. Okay. Now, what's left? On the top, I have a 2 times a 7 and a y, y, y. What's 2 times 7? And we would usually write that y to the third power. What's left on the bottom? 13 and 3. That's 13 times 3. And so this is the simplified, reduced answer. Look at this final answer right here. Is there anything right here that can be reduced some more? Because sometimes when you're doing the problem, you miss one of the some of the reducing, so you always check your answer and make sure that it is reduced completely. Now, I didn't mention this part right here. These are my excluded values. Back here in the original problem, x cannot be equal to 0 because the denominator can never be equal to 0. Right here in the original problem, the y cannot be 0 because the denominator can never equal 0. So this is pretty much the same thing that we were doing on the simplifying. We even did some problems like this when we were doing the exponent paper. So expand everything out and cancel as much as you can. When you have a binomial, you're going to factor first. Factor first. When you have a binomial, you look for a GCF. In problem number 2, this very first numerator right here what factors out of that numerator? 3 and 6. What divides 3 and 6? Well, 3. And you see they both have an x squared or higher. If I take this and divide it by 3x squared, I have an x left. 6 divided by 3 is 2. The x squareds would cancel out. That's the first numerator. This denominator, what's going to factor out of this denominator? This is like doing the distributive property backwards. It's undistributing. So this second fraction, 4x, is going to factor out of both of those. If I take a 4x out of that, an x is left. If I take a 4x out of that, 1 is left. This, what factors out of 6 and 12? Now, it's all factored out. To multiply fractions, you multiply numerator times numerator, denominator times denominator. All of this stuff is multiplied together on the top. All of that stuff is multiplied together on the bottom. It's all one great, big, huge, ugly fraction. To make it look better, we're going to cancel as much as we possibly can. So, will anything cancel? I don't know. Where do you want to start? You want to start with the 3? 3 goes into what? 6, 2 times. And so then, is anything going to cancel the x squared? So I'm going to cancel this x with that x, and so nothing's going to cancel the x squared. Will anything cancel the x plus 2? And the x plus 2? X plus 1? X plus 1? So, what's left? I have a 4 and an x squared on top, and we usually put the whole number before. We put 4x squared and not the other way around. What do I have left on the bottom? Now, look at that. Will that reduce some more? I missed one of the canceling. Will that reduce some more? Will 2 go into 4? 2 will go into 4 2 times, so that's 2x squared is my final reduced answer. My excluded answers came from this factored form. This x cannot be equal to 0. This term here cannot be equal to 0. I can't have a negative 1 here, because if I added it to a positive 1, that would zero out. 6 isn't equal to 0 anyway. This one right here, I can't have a negative 2 right here, because then when I added to 2, that would make it equal to 0. These are my excluded values. The denominator can never be equal to 0. Example number 3, you factor first. In this first denominator, is there a GCF? No. But 9 is a perfect square number. Minus a perfect square number is a difference of 2 square pattern. Some of you have never learned how to factor a difference of 2 square patterns. So I have put them up here in your notes. Don't copy them right now. I'll put them up on the board at the end, and you can take a picture of it if you want to. But this is our numerator in this problem, and it factors into x plus 3, x minus 3. 3 times 3 is 9. The denominator is x squared minus 4. This is the denominator in our problem. it's a difference of two squares. It factors into x plus 2, x minus 2. 2 times 2 is 4. This one right here isn't the difference of two squares, but what divides 4 and 8? And so I'm going to factor out a 4x, so I'm going to have an x minus 2 left here for that numerator. This last denominator, what divides 6 and 18? So, x plus 3 cancels x plus 3. X minus 2 cancels x minus 2. Anything else will cancel? What about the 4 and the 6? What divides 4 and 6? Those both reduce by 2. So 2 will go into 4, 2 will go into 6. So, what's left? X minus 3, and then a 2x, we would usually write that in front. X plus 2, and this 3 we would usually write in front. Now look at your final answer. Is there anything that will reduce some more? No. And then these excluded values came from this denominator right here in fractored form. This can't be a negative 2, because that would make this go to 0. This can't be a positive 2, because that would make this go to 0, and zeros in the denominator are not allowed. This cannot be a negative 3, because that can't be 0. You're excluded from the fact that the denominator cannot be equal to 0. And then we have some trinomials. But what do we still do first? Factor and show that first numerator right there doesn't have a GCF, so you multiply the first number times the last number, and you write down the factors of negative 3. Which pair is going to add up to give you a 2? X minus 1, x plus 3. Now, this denominator has a GCF. A 4 will factor in that denominator. That's going to be x squared plus x minus 2. And then this right here has a GCF of 2, x squared minus 4. This, when you multiply the first number times the last number and you write down the factors of negative 6. And so this is what I'm going to use. And so this is going to be x minus 2, x plus 3. It factors some more. Okay. Once I got my... This part right here is a perfect square minus a perfect square. So this factors into x plus 2, x minus 2. This numerator right here doesn't factor anymore. This part right here factors some more. The factors of 2 are 2 and 1. Now it is factored completely. I didn't do my excluded values. Let's go ahead and do that. X cannot equal to negative 2. Right here, X cannot equal to positive 1. X can't equal to positive 2. And X cannot equal to negative 3. The denominators, none of the terms in the denominators can equal to 0. Okay, now we're ready to start canceling out. Will anything cancel out with X minus 1? X plus 3? Anytime you have 1 on the top and 1 on the bottom, you can cancel it out. 1 on the top cancels 1 on the bottom. And this one cancels that one. And so, is that all my canceling? What is left? 2 on the top and 4 on the bottom. What is 2 over 4 reduced to? And so, all of that big, long problem reduces to 1/2. That's the final reduced answer. We're going to skip problem number 5 right now and go ahead and do look at the division, because the division is going to be what is a little bit tricky. Please underline this part, highlight this part, put stars and arrows by this part. The way that division is different than multiplication is to divide, you turn the second fraction over and multiply. Now there's a whole long explanation about why you do that we don't have time for in this class. We're just going to tell you the how to. You were supposed to have been taught the why in a previous grade. If you weren't, you can look it up on Google, of course. And so, and y'all were never taught the little rhyme, to divide fractions, don't ask why, turn the second one over and multiply? Okay, well now you have been. For division, don't ask why, turn the second one over and multiply. You can ask why, just don't ask me, ask Google. So, I am going to, problem number 6, to divide, I'm going to take this second fraction, the divisor, turn it over, and multiply. Turn it over means the x that was on the top is now an x on the bottom. The 2x to the third minus 2x squared is now on the top. Now it's a problem just like the 4 examples I did previously. You factor it and you cancel. This first numerator does not factor. This denominator factors out a 2x. This numerator factors out a 2x squared. I have made a mistake. Did you catch my mistake? If you take a 2x out of that, that would be a squared right there. I lost one of my squareds. This will factor some more. I have the 3x minus 1 on top, the 2x, x plus 1, x minus 1. 1 is a perfect square number, so it factors into this plus and minus pattern. And so this would be 2x squared, x minus 1. I expanded this to make it easier to cancel. It's not necessary. You don't have to, but sometimes it makes it a little bit to cancel. Is there anything that's going to cancel the 3x minus 1? Now that I've got it completely factored, I cancel. This 2 is going to cancel this 2. This x is going to cancel that x. This x minus 1 is going to cancel this x minus 1. This x is going to cancel that x. So, what is left? What do I have left on the bottom? The excluded values come from this part right here before I canceled anything out. That x cannot be equal to 0. This x cannot be equal to -1, because that would make that go to 0. This x can't be equal to +1, and this x can't be equal to 0, so I already have that. And so these are my excluded values. To divide fractions, don't ask why. Turn the second one over and multiply. The x plus 5 goes to the top, the x minus 1 goes to the bottom. But that first part's not a fraction. So I have to make it into a fraction. Now it's a fraction. And so to factor -1, x squared minus 1, that is, this is how x squared minus 1 factors. We only have one excluded value this time. And so this cancels that. So what do we have left? We have x plus 1, x plus 5, and a 1 in the denominator. Now, 1 in the denominator means you're dividing by 1. If you divide by 1, do you change the value of something? Does it make it more or less, or it stays the same if you divide by 1? The answer would be it stays the same, and so you would not need to have that divide by 1. Now, you could take a box problem and multiply that answer out and put the answer in standard form, but it's not required. So you can leave it in factored form if you would like to.